So this is going to be a very short video, but still a very important video. In this video, I'm going to show you how to trace invert the Einstein field equations. People see this alternative version and sometimes wonder what it is. A lot of people that know what the Einstein field equations are don't also know what these are or exactly where they come from. It turns out that in fact they are equivalent equations to the normal Einstein field equations, and only a few lines of algebra is enough to conclude them from the Einstein field equations, but still occasionally I get questions about it, and it's something that, while it's very easy, perhaps to a beginner it's not obvious. So in this video I'm going to show you the extremely short procedure required to trace invert the normal Einstein field equations to get the trace inverted equations. The math section is super short because it is really easy, if not necessarily obvious at the get-go. Unsurprisingly, from the name trace inversion, the first step to trace inverting the Einstein field equations is to take the trace. Now we will denote the trace as the same letter that the tensor was denoted with, except without the indices. Also, it's important to remember that the trace of the metric is just the dimensionality of space-time, which of course is 4. So if we simply contract a metric across all of these, both indices, then we arrive at this result here. Then if we multiply by -1/2 times the metric, then we arrive at this. Now the key here is that we can then subtract the Einstein field equations, meaning this term here cancels with that one, and we arrive at here, the trace inverted Einstein field equations. So it really is every bit as quick and easy as I promised. So now you've seen how to trace invert the Einstein field equations. Despite the fancy name and the complicated equations that are involved, none of the complexities of the Einstein field equations really manifest themselves in the problem. It's super simple. Hopefully this answered your question if you're a beginning general relativist and didn't know where they came from. And the reason why they are used is because sometimes they make the math easier, and that's basically it. If you found this video useful, give it a thumbs up and don't forget to subscribe. D-Trick out.